People, time for our next two-dimensional shape in our geometry unit. We've done parallelograms, we've done triangles, and now we're moving on to our third shape, which is the trapezoid. What you've got here drawn on the screen is one type of trapezoid. I could also freehand another trapezoid. So you've probably seen figures that look like this. Actually, we had one in our triangle classwork as a bonus problem. But trapezoids also sometimes look like this. What makes a trapezoid is that it is a quadrilateral, so a four-sided figure that has one and only one pair of parallel sides. So in this trapezoid, this side and this side are parallel to one another. They run parallel, but the other sides do not. One pair of parallel sides and it's a quadrilateral, that's a trapezoid. In this figure, this side and this side are parallel to one another. The other two sides are not. That makes this a trapezoid. Four-sided figure with one pair of parallel sides. Now, what we want to explore is how do you find the area of this type of figure? So there is actually a really wacky formula that you can use to find the area of a trapezoid. But before we do that, what we need to talk about is what are the important parts of a trapezoid. Like in a triangle, we've talked about it has a base and it has a height. In a parallelogram, same thing, a base and a height. In a rectangle or a square, length and width. In a trapezoid, you'll notice that there's two sides that are parallel to one another. The other sides are not. The things that we have in a trapezoid, are right here. B1, B2, and H. Those are the important measures. What the heck do those two things stand for? Well, the first thing that you should be able to pretty easily figure out is H. H stands for height. Height is the straight distance that goes from one base to the other. So in this, if I drew something here with a right angle, that would mean it's a straight line that connects these two sides. This is the height. And I said that the height runs between the two bases. In a trapezoid, there is not one, there are two bases. We call one of them B1 and the other one B2. The bases are the two parallel sides. So in this trapezoid, these are considered the bases because they are the two sides that are parallel to one another. These other two sides are nothing. They're not relevant in finding the area. And I get this question a lot, so I'll point it out. It doesn't matter if you call the top B1 and the bottom B2, or if you switch that around. The little 1 and the little 2 are just labels, so that we have base 1 and base 2. We can't just call them both B, because very clearly they're not the same length. One is shorter and one is longer. So instead of using two different variables, we just call it one of them B with a little 1, base 1, and B with a little 2, base 2. All right, now if you can understand that those are the three parts of the trapezoid that are relevant to finding the area, we can get to the area formula. Here we go. It's a little bit weird, but to find the area of a trapezoid, you can use one of two formulas. You can do base 1 plus base 2. So no matter what, you need to find the sum of the bases, whatever this length is, plus whatever this length is. And then you need to half that, so divide it by 2. All of that needs to be multiplied by the height of the trapezoid. Sum the bases and cut that value in half, multiplied by the height. Some people prefer to write the formula another way, and actually I'm one of those people. I like to write it like this. Base 1 plus base 2. No matter what, we've got to find the sum of those two bases times 1/2 times the height. I like to take the division out of it. Dividing by 2, multiplying by 1/2, it means the same thing, but especially when we get to problems where one of the parts of the trapezoid is missing, I like to have this formula. It's totally up to you. It doesn't matter which one you choose. Both of them will yield the same answer, but you're summing the bases, cutting it in half or dividing by 2, and multiplying by the height. Now, with that formula, let's do two example problems. I'll try one and give you a shot on the other, and that'll wrap up this quick lesson on trapezoids. The first one we'll do is this green trapezoid, and I'm going to cover up the other one so we're not distracted. All right, so the formula, I'll write it out. We are going to sum the bases, b1 plus b2, half that, and then multiply by the height of the trapezoid. In this trapezoid, the height is this side actually, because it's running straight distance from the bottom to the top, from base 1 to base 2. So our height is 6, and our two bases are 9 and 5. So plug all that in and then just compute. 9 plus 5 is 14. 14 times 1/2 is 7, and 7 times 6 gives me a final area of 42 feet squared. So base 1 plus base 2 times 1/2 times the height. All right, let's give this a shot on the purple second example. I'll pause and give you a moment to examine the figure and try to put it into the formula and see what you can come up with as a final answer. And don't worry about typing in a label. Let's just see if you can get the numeric part of the answer correct. All right, let's see how you did. Hopefully you did 8.5 plus 11.5. Cut that in half, multiplied by 5. So 8.5 plus 11.5 is 20. Half of 20 is 10. Times 5 is 50. And the label would be meters squared. Area is always units squared. And that's it. We're obviously going to build on this and do a lot more with trapezoids in class, but as a springboard introductory lesson onto how to find the area of trapezoids, here it is. I'll also in class explain where that formula comes from if you're interested. It's not just a weird made-up formula. It actually is based on shapes that you know. So we'll talk about that in class as well. But for now, that's it. If you've got questions, let me know. Otherwise, see you in class. Bye.